Hi, this video is all about relations and functions. So let's define first what is a relation. A relation is a rule that relates values from a set of values called the domain to a second set of values called the range. The elements of the domain can be imagined as input to a machine that applies a rule to these inputs to generate one or more outputs. So again, a relation is anything that takes an input. So we have different set of inputs. We have numbers, it can be letters or anything that will represent an element. And again, if this machine will represent a relation, so we are expecting to have one or more outputs. So for example, my input is 3, maybe this relation will give me an output of a single number like 1. Or maybe this one will give me two set of numbers like 1 and 2. So let's consider this table. So I have here is input and output. Let's say on a relation, let's say my input is 3. So maybe I have an output of 1. Maybe if I have an input of -2, I have this output as 5. Let's say I have this input of 3 and my output is 2. And let's say I have -1 as my input and output of 4. Now, we can represent a relation in several ways. So we have table, ordered pairs, graphs, and mapping diagram. So table of values is just a graphic organizer or chart that will help us to determine two or more points that can be used to create your own graph. So before we graph or plot a points, we usually need to create or construct table of values. So for example, we have here the x or the domain and we have the y or the values of our range. Let's say we have 3 and 2. Let's say I have -2 and 1. Let's say we have 3 and -2. Let's say we have -4 and +3. So those are the values. Let's say we will represent different relation with the use of this table. Now, in terms of ordered pairs, so we know that ordered pair is just a composition of x coordinate or the abscissa and the y coordinate or the ordinate. So we are pairing this set of values with fixed order. So that order will be x and y, and we will enclose this with the use of parentheses. So let's transform this table into a set of ordered pairs. So we have this one will became so we have 3 and 2. So this one is -2 comma 1. So this is 3 comma -2, and this point is 4 comma 3. So that is our ordered pairs. Now, basically, if you want to graph something, if you want to graph points or ordered pairs, we need this Cartesian plane. So we need to plot the points here. So let's say we have 3 comma +2. So we have 3 comma +2. So we have 3 here as x value, and we have +2. So their intersection will be 3 comma 2. Next, we have -2 comma 1. So we have here this negative value of x and +1. So we have -2 and +1. This is their intersection. So we have -2 comma 1. Next, we have 3 comma -2. So we have again 3, and we have a negative value. So that is below. So that is 3 comma -2. And then last is -4 comma 3. So we have here this value of -4 comma +3. So 3 units upward. So we have here this point. So we have -4 comma 3. Now, last is the mapping diagram. So mapping diagram will show how elements are being paired. So it's like a flow chart for a function showing the input and output values. So this first set of circle will represent the values of our domain or the x values, and this one, second one, will represent the values of our range. So we simply need to list down all of the values here. So for example, we have here this domain. Let's extract all of the values of our x here. So we have negative 2, negative 4, and positive 3. So as you observe, we have here two set of positive 3. So with use of mapping diagram, we can simply write it as single number. Now, let's list down the values of our range with use of our y values. So we have negative 2, 1, 2, and positive 3. So since this is a mapping diagram, we need to um, show the pairing of our values. For example, 3, positive 3 here is paired with positive 2. So we need to construct a line. So this 3 is being paired with positive 2. Next, negative 2 and 1. So we have negative 2 and 1. Next, we have positive 3 and negative 2. Positive 3 and negative 2. And last is negative 4 and positive 3. So negative 4 and positive 3. So again, on constructing mapping diagram, it's either we will use a table, ordered pairs, or graphs. Now, let's answer this problem. Identify the domain and range of the relation. Represent the relation using ordered pairs, a table, and a mapping diagram. So again, let's construct first um, the representation of this graph with use of ordered pairs, table, and mapping diagram. And then later we will solve for the domain and the range. So for example, we have here this Cartesian plane with some points. Let's construct its ordered pairs. So let's say this point is point A. So this is negative 3, comma, positive 1. So for point A, we have negative 3, comma, positive 1. Now, let's name this point as point B. So that is under negative 2, comma, negative 2. So for point B, we have negative 2, comma, negative 2. Now, let's name this point as point C. So that is from positive 1, comma, positive 4. So C is positive 1, comma, positive 4. So let's name this as D. D is positive 2, comma, positive 1. So we have 2, comma, 1. And last, this point as point E. So we have 3, comma, negative 1. Negative 1. Okay. So now, let's construct table of values. So again, it is just a set of values of x and y. So we have the first point is negative 3 and its y value is 1. So we have negative 2 and another set of negative 2. We have here this point C with x values of 1 and y as 4. For point D, we have x as 2 and y value as 1. And last, for point E, we have 3 and negative 1 as its y value. Now, let's construct a mapping diagram that will represent this relation. So, again, we need to construct a circle that will represent the values of our domain and range. So, just construct two set of circles here and list down the elements. So, for example, we have here this element. So, we have negative 3, negative 2, 1, 2, and 3. We have this point 1, negative 2, 4, and negative 1. And we need to show their pairing or the line. So negative 3 is paired with positive 1. So negative 3 to positive 1, negative 2 to negative 2, negative 2 to negative 2. We have 1 and 4. We have 2 and 1. So we have 2, positive 1. And we have 3 and negative 1. 3 and negative 1. Okay, so now let's list down the values of our domain and the values of our range. So for our domain, we have this set of values. We have negative 3, negative 2, 1, 2, and 3. And the values of our range are we have 1, negative 2, 4, and negative 1. So again, with the use of this detail, we can represent this graph as an ordered pair, a table, and a mapping diagram. Now, let's proceed with functions. Again, a function is a relation where each in the domain is related to only one value in the range by some rule. The elements of the domain can be imagined as input to a machine that applies a rule so that each input corresponds to only one output. So this is the unique thing here. So if we have this function, let's say this is our function machine, if we take an input, okay, so let's say I put a number, let's say 3, so it will always give us only one output. So for example, this is 3 as my input, and this machine will give me only single number. Let's say I have negative 1 as my output. So let's say I have here this graph. Let's say I have 3 and my output is negative 1. Let's say I have 2 and my output is, let's say, 4. Let's say I have 1 and my output is 0. And let's say 0 and my output is, let's say, 5. Okay? So let's proceed. Now, let's solve this given situation. So, is it a function or not a function? So, let's try to observe the values of our ordered pairs letter A. So, we have negative 1, comma 4, 2, comma 3, 2, comma 7, and 8, comma negative 1. So, again, if this is a function, therefore, for every values of our input, we only have a single output. So basically, we need to observe the values of our x. So since an ordered pair consists of x and y values, so this 2, comma 3 and 2, comma 7, they contain the same value of our domain. Therefore, A is not a function. Now, let's try to solve the ordered pair letter B. So again, we have here 2, comma 7, negative 1, comma 7, 2, comma 7 again, and 3, comma negative 1. So since we have here this same element, we have 2, comma 7 and 2, comma 7, we can simply represent this or write this in a single 2, comma 7. Therefore, so since we have 2, we have negative 1, and we have 3 as our domain, therefore, this B is a function. Now, let's proceed. For example, what if we are asked to determine if the given graphs are function or not a function? So, basically, we have here the step to determine if the graph is a function or not a function. So, we have this vertical line test. Now, what do you mean by vertical line test? So, we simply need to construct a vertical line. So, for example, for this graph A, just construct a vertical line and observe that this line intersects our graph at 2 points. Okay? Therefore, A is not a function. Next, for point B, so let's construct a random vertical line. So again, this line intersects our graph with exactly 1 point. Therefore, this is a function. And last, for graph C, let's construct again vertical line, and it intersects our graph with exactly 2 points. Therefore, this graph C is not a function.